Welcome, everyone. Today, we're taking an absolutely epic journey. We're going to travel all the way back through time to uncover the sweeping, incredible history of our planet. Going from a chaotic swirl of dust out in the vastness of space to the vibrant, complex, totally life-filled world we call home today, the story of Earth is it's nothing short of breathtaking. 4.54 billion years. That is the staggering age of our Earth. It's a number so huge, it's honestly kind of hard for the human mind to fully wrap around. To put that crazy figure into perspective, our planet has been around for roughly a third of the age of the entire universe. Just imagine the countless biological and geological transformations, the rising and falling of oceans and continents that have happened over such an unimaginable stretch of time. Okay, let's dive into this. Here's our chronological roadmap for today's explainer. We'll start right at the beginning with the origin of Earth, look at the early atmosphere, explore the pivotal beginning of life, see how oxygen and complex life completely transformed the globe, and finally, we'll wrap up with the geological timescale. Section 1. The origin of Earth. So, Earth didn't exactly just peacefully pop into existence. It was built through a really violent cause and effect process. First up, we've got solar nebula accretion, which is essentially just cosmic dust and gas violently colliding and clumping together. Because of all this heat and extreme activity, the early Earth was basically in a molten rock phase, completely dominated by intense volcanic eruptions. Then, something absolutely monumental happened, a massive collision with a Mars-sized planetary body. This unbelievable impact was so powerful it actually tilted the Earth on its axis and created our moon from the leftover debris. Eventually, though, things started to calm down. The planet began to cool, a solid crust formed, and that allowed liquid water to finally accumulate and create our very first oceans. Moving right along to Section 2, the early atmosphere. And this brilliantly illustrates the dramatic, almost unbelievable contrast between the world right after its formation and the world we know right now. That early atmosphere? It was a direct product of extreme volcanic outgassing. It was totally toxic, with absolutely zero oxygen. If you or I were transported back in time to this era, we literally wouldn't survive for more than a few seconds. Now contrast that with our modern atmosphere. It's life-sustaining, it's rich in oxygen, and perfectly breathable for us humans and other complex life forms. How we transitioned between those two extremes is definitely one of the greatest chapters in Earth's history. Which brings us to Section 3, the beginning of life. Now, you might be wondering, how do we actually know when microscopic life first appeared? Scientists aren't just guessing about this stuff. They have concrete physical evidence locked away in ancient rocks. For example, in western Greenland, deep within sediment dating back a staggering 3.7 billion years, researchers actually discovered biogenic graphite, which are essentially the carbon signatures left behind by living organisms. And in Western Australia, down in ancient sandstone dating back 3.48 billion years, scientists have found actual microbial fossils. These tiny microscopic pioneers were the very first forms of life, just surviving and multiplying in a really harsh, alien-like world. Next up, Section 4, oxygen and complex life. So we know the first life forms showed up roughly between 3.8 and 3.5 billion years ago, and that's backed up by our evidence from Greenland and Australia. But the ultimate game changer happened around the 2 billion year mark. That's when photosynthetic organisms evolved. They started taking in energy and releasing this vital byproduct, oxygen. Slowly, over millions and millions of years, they literally pumped our toxic atmosphere full of breathable oxygen. And because of this massive environmental shift, around 580 million years ago, the atmosphere was finally ready, and complex multicellular life was able to emerge. This newly oxygenated environment set the perfect stage for an absolute explosion of biological diversity. Enter the Cambrian period. Instead of just simple microscopic organisms, Earth suddenly saw an incredible variety of complex and frankly quite bizarre-looking animals rapidly developing. This massive diversification essentially laid down the whole evolutionary foundation for the major species and ecosystems we recognize today. Now, why does all of this matter to us right now? Well, it's because the biosphere, meaning all living things, actively shaped the physical Earth itself. Think about it. The biological actions of past life forms created the protective ozone layer that shields us from harmful solar radiation. They increased atmospheric oxygen, giving us the very air we breathe. They even drove the formation of the nutrient-rich soil that grows our food. Life didn't just happen on Earth. The biological actions of past life forms literally built the safe modern environment we live in today. Let's move to Section 5 and see how this builds into the geological timescale. So, how exactly do scientists keep track of this immense continuous history? They use the geological timescale. It's basically a chronological system that categorizes Earth's massive history into distinct, manageable eras. They do this by reading the planet's history directly from the stone beneath our feet, studying layers of rock in a process called stratigraphy. You can picture it like this. Each distinct layer of rock acts almost like a page in a giant ancient history book, holding the secrets of past climates, biological extinctions, and major evolutionary leaps. And we've got to remember, Earth's story is far from over. Plate tectonics are continually reshaping the planet as we speak. The surface of our world is literally shifting right now. These shifting tectonic plates are constantly rearranging oceans, moving massive continents, and profoundly influencing the ongoing evolution and sometimes the extinction of life on Earth. Our planet is a dynamic, active system, and it is still writing its history in the rocks today. Which brings us to a really fascinating final thought to wrap up our journey. We've seen how tiny, microscopic life completely changed the planet's atmosphere, and how massive historical events left their permanent mark in the rock layers beneath us. So my question to you is, knowing how deeply life shaped our past, how will our current era be recorded in the geological timescale millions of years from now? What footprint are we leaving behind in the stone? Thank you so much for exploring this deep history with me today, and I absolutely can't wait to guide you through our next explainer.